Good evening, children. Vatsala, good evening. Good evening. So, as we have started long back about the language of chemistry, so as you know very well about this concept, just we go in brief recapitulate this session so that it will be like continuity to the next coming session. Okay. So we'll go a bit slowly. Okay, not in hurry because it's I think it took more than 2-3 weeks. Okay, so as we know that introduction language of chemistry, so how we have alphabets like A to Z. These A to Z combines to give different like English language, so that's why we are communicating, and I'm able to explain you so that you can understand what I'm explaining. Though it is I'm explaining about chemistry, but how I conveying the subject, children? How I convey English with from English, how English is framed and how English communication got developed within this A to Z, that is 26 alphabets. Am I right? At the same way, so for the language of chemistry, it's very, very important. Now we are learning water, H2O, oxygen, O2, hydrogen gas, H2. So all these different gases with symbols we are learning. So this is nothing but, these are nothing but language of chemistry. Understood? So this language of chemistry also from alphabets only, but there is a different terminology which we use in this part of science. What is the part of science, children? Chemistry. Chemistry. This is one of the branch of science. Understood? So there are some technical terms expressed in the term of chemical equations. So as symbols and formulae. So different kinds of things we have to learn. So as very much familiar about the language, so first one, language, what we can say that technical terms are important. Chemical equations will represent symbols and formula. So these are the different things we'll use in this language of chemistry, especially when we go with sodium. For sodium, Na is the symbol. For sodium, Na is the symbol. Like that equation. What equations will represent in chemistry like H2? H2 plus O2 gives rise to H2O. C plus O2 gives rise to CO2. C plus O2 gives rise to CO2. Carbon dioxide. Carbon plus oxygen reacts chemically. C plus O2 gives rise to CO2. That is nothing but simple chemical equation. And we are representing the elements with symbols like sodium Na, calcium Ca, calcium carbonate CaCO3. So these are the different kinds of symbols which we use in the language of chemistry. Understood? Understood or not?
Yes, ma'am.
Yes. So though we have discussed all these are the basic concepts for the for your higher classes, because this is very, very, very important. Until and unless you are perfect with the technical terms, symbols, equations and formulae which forms the language of chemistry. Understood? Understood or not? So this is about the introduction part. So at present, how many elements are there, children?
118.
At present, we are having 118. This 118 is common in the entire world. It's common for every country. Not only India 118. Even if you go to... Yes, Bhavya? What, Bhavya?
Ma'am, we have all we have total we have all 118 elements, but we never. I don't think we will learn all the elements.
No, it's very easy. Once if you know the technique of learning all 118 elements, it's very, very easy. So at a time we can't eat this much of food. we feel like saturated. So when we are hungry, one thing I can say, when we are hungry, we feel like eating this much. Understood or not? Beyond our capability, we feel like eating once we are very much hungry. Okay. So after start eating, by eating this much itself, we feel like it's saturated. Saturated means filled up. If we want to eat excess also, we'll feel like vomiting. That is saturated. Okay, beyond that, our capability won't support us to eat that excess or to take that excess. That is called saturated. Then how we'll eat? We want to eat this much, but our capability of eating only this much. So how we'll eat, children? We'll eat quantity. We'll break the quantity into many parts so that little bit quantity at the first part, so that gradually we'll divide the quantity. At last, we'll complete eating that entire food. Understood or not? So at the same way, here 118 elements are there. To remember, to memorize all 118 elements, it's very, very, very difficult. Even I felt difficulty when I learned. Understood? So at the same way, how we will take this 118 element? These 118 elements are divided into groups and periods. Groups like vertical lines, periods like horizontal lines. If we learn according to the groups and periods, so that each day learn 5 groups, 2 periods. 5 groups, 2 periods, it's not much difficulty. Divide like that and you can read. If you want to read. If not, according to your standard, till your standard 10, 1 to 30 elements are so much. But if you are very much curious of learning all 118 elements which are present in the periodic table, go ahead by going with the technique, like divide the periodic table into groups and periods so that you can easily learn all 118 elements in a rhythmic way. Helium, neon, argon, krypton, xenon, inert gas element. Sodium, potassium, magnesium, calcium, rubidium, cesium, francium. First group element. Third period, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, like that. Third group element. So you divide the groups and periods so that you can easily learn one vertical line and one horizontal line. So that you can complete by within a week, we can complete reading all 180. But according to your standard, you can go with 1 to 30 elements up to your class 10. Any doubts? Any doubts?
No, ma'am.
So this 118 element discard so far. So at present, there were 3 more elements got founded, but they have not given they are not recognized by IUPAC. What do you mean by IUPAC?
International Union of Pure and Applied Chemistry.
Yes, International Union of Pure and Applied Chemistry. How we are having GVMC, like GVMC in the sense municipal corporation, which we feel like whenever we got a birth, so immediately our names get registered. Until and unless the names got registered. What, Arna?
Can you tell the full form again?
International Union of, I'll write. International Union of Pure and Applied Chemistry. So here, though we find out the elements that these elements should recognize by IUPAC, International Union of Pure and Applied Chemistry, then only we'll get all these elements. So within that 118 elements, 92 elements occurs naturally, 92 elements occurs naturally, and 26 are artificial or man-made. 96 elements are naturally occurred and 26 are artificial or man-made. Understood? How these man-made elements got found? How they were formed? So, by doing chemical reactions, for example, I want to prepare from the pure milk, understood? So from the pure like a cream milk directly from the cattle, if we boil it so that we'll get cream. We'll take out the cream and we'll get different components, different varieties of milk food items. Am I right? Understood? So when we are doing each item is having its unique property, its unique characteristic. At the same way, when we do the chemical reactions, what compound we want other than the wanted compound, unwanted or surprised compounds are also got found. Understood? So I'll do the chemical reaction so that one kind of compound I got. One product I got. Other than the product, different components are also found. So maybe the different components are mainly, so if it is of any other kind, which are like unknown, surprised one, by fortunately we got the other compound, so that they'll analyze on that. When they analyze on that element, so they'll feel like, okay, this element can be this. So this can be placed under this. So they give their views, they give their ideas, they give their explanation to IUPAC. Okay. So when they give their explanation to IUPAC, if these explanation parts are correct, they feel like IUPAC feel, so definitely they'll recognize and they'll give the name and definitely they'll place the element in the periodic table. Understand?
Yes, ma'am.
So next important thing. So what do you mean by element? Elements are pure substances. So we are having 118 elements which are very much pure. So that's why they are placed in the periodic table. These elements cannot be broken down into two or more simpler substances by any chemical means. That means if I want to break iron, from the iron, only iron atoms are present. That means when I break the iron atom, I'll get only iron. When I break the iron element, I'll get only iron atoms. No other elements can be present. That means these elements are very, 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 very pure. Understand? So how many pure elements are there, children?
Ma'am, 92.
92? No, all 92 and 26, all are element itself is a pure. You understand what I'm saying?
But artificial
means they are prepared by man. If they are prepared by man also, they are pure. Understood? Those are nothing but radioactive elements. Radioactive elements are very pure. That's what they're used in nuclear activities. Oh. Until and unless the element is not pure, they won't involve in reacting the compound. Understood? Yes or no? Are you getting what I mean to? Yes.
Yes, ma'am.
Yes. So all 118 elements are very, very, very pure. Whether they are obtained naturally, whether they are prepared by man, whether they are called as artificial or whatever. All the 118 elements are pure. In what sense they are saying that they are pure? Why? Because if I want to take a gold element, I'll break the gold element into simpler pieces. When I break the gold element, we'll get only gold atoms. No other atoms are present. That means no any other impurities or no other unwanted things or no other any other things are present in it. So that means it is pure. Is it pure?
Yes, ma'am.
Yes. In that point of view, they'll say that elements are pure. Because when we break the element or when the element breaks into simpler pieces, we'll get only the element of that, atoms of that element. If I'll break iron, I'll get only iron. I won't get hydrogen or oxygen in it. If I'll break oxygen element, I'll get only oxygen atom. Is there any other hydrogen and carbon is present in oxygen element? Yes? I want the answer from the children. You are very quiet. Why?
No, ma'am.
Vatsala? Bhavya? Arna? Priscilla?
Only
anyone wants
oxygen
it?
elements will, oxygen atoms will be there in oxygen element.
Yeah.
Yes, ma'am.
Oxygen
Ma'am,
element,
two
when we
oxygen
break the oxygen element, we'll get oxygen atoms. So when
Yes,
we break oxygen, we won't get hydrogen, or we won't get carbon, or we won't get any other atoms.
Okay, ma'am.
Understood?